Hello everyone. It is my pleasure that we are starting our journey together in YouTube with this monumental success of ISRO. So let us all take a moment to congratulate India and ISRO on achieving this great milestone. Finally, we have become the fourth largest nation to have docking ability via our SpaDEx mission. So let's dive in further. You might be wondering, what is SpaDEx? SpaDEx is Space Docking Experiment Program, and it is one of the latest developments by ISRO as an initiative to develop docking ability between two spacecrafts in orbit. The next question that comes up is, what is docking and how does it even matter? Let us assume there are at least two fast-moving spacecrafts in our orbit, and we want to establish a coupling or a connection or a joint between them in that same orbit. The process via which this can be achieved is known as docking, where they are slowly brought close to one another and finally joined or docked. This is something that you might have observed ships doing in the harbor. Now there are two types of docking. One is soft docking, another one is hard docking. Soft docking is that first step where we are establishing a preliminary connection to test the alignment and the grip between the two crafts. Hard docking is that final mechanical lock where we are securing the structural stability between them. So now you may be wondering, this all sounds so simple. So why do we have to spend so much money for achieving such a simple task? But there are a lot of different steps involved. So let's dive in further. How does SpaDEx even work is the first question that we will address. SpaDEx satellites are carried in a large satellite carrying vehicle called Polar Satellite Launch Vehicle. The SpaDEx satellites consist of two spacecrafts, A and B, each with a mass of 220 kg approximately. And during docking, either of them can act as the chaser and the target. So imagine two spacecrafts A and B with 220 kg mass traveling at a staggering speed of 28,000 km per hour is performing a space handshake between themselves. And they are separated initially by a distance of 20 km. However, as they keep approaching towards one another, their final velocity drops from 28,000 km per hour to 10 mm per second, and the in-between distance reduces from 20 km to 3 meter in steps. Putting this 28,000 km per hour speed into perspective, this is 30 times faster than our typical airline speed. Speed of 28,000 km per hour, the spacecrafts are performing handshake in space in a particular orbit with a mass of 220 kg each, and the distance is brought down from 20 km to 3 meter, and we need this precision to perform the handshake finally. And all of this is done via telemetry remotely from Indian Space Station. The two spacecrafts coordinate the momentum between themselves with the help of multiple sensors and algorithms at each step of the handshake journey, maintaining their position using various thrusters. Spacecraft A contains high-resolution camera and spacecraft B contain payloads which are needed for monitoring natural resources, vegetation, and on-orbit radiation. Now the docking happens in three phases. Separation of spacecrafts from carry vehicles followed by a controlled drift is the first step. Second step is safe and controlled sequential approach of these two spacecrafts closer to one another. And then a final step where the docking or the coupling is happening, followed by a capture, a retraction, and a rigidization. Now that we have established how SpaDEx works, the immediate next question that comes to mind is, why do we even need SpaDEx? I mean, it is not something that we need in our everyday life, right? However, that's not the case. We will discuss in this video further how SpaDEx or this docking ability is helping us in everyday life. Let's tackle why do we need SpaDEx first. Currently, it takes approximately 130 crore Indian rupees to launch a large satellite and rupees 30 crore to launch a small one. Now that we have achieved docking, we can repair and refuel the already launched satellites. This will improve the operational lifespan of those satellites by approximately 10 years, and we need not send additional satellites to perform the same task. This will reduce our space junk and debris. So we are reducing the cost of new mission We are improving lifespan of existing satellites. We are reducing the number of new missions, and we are also reducing the space junk with this just one docking ability. Also, we want to set up our own space station similar to US and Russia, and we will be calling it Bharatiya Antariksh Station. The docking initiative will enable us to assemble large components in space and enable transfer of crew and cargo between the spacecrafts without the need for a spacewalk, and the absence of this spacewalk will reduce the risk for the astronauts drastically. What does SpaDEx contain? SpaDEx contain total 24 payloads. 14 of them are from ISRO and 10 of them are from startups and academia. These payloads contain different parts and components, which you can see in the screen in front of you. We have included the top 3 from each of ISRO and academia or startups. However, there is a detailed list and explanation of what each of these modules does in the ISRO official website, which I will link in the description below. Coming to the next big question, which is how much is the government spending towards Indian space program and why? India spent 0.05% of a GDP in space program, whereas USA and China spent 0.23% and 0.15% respectively. For the fiscal year 2024-2025, India has allocated $1.6 billion to the Department of Space, which is approximately 4% higher than the previous year. Putting this $1.6 billion figure into perspective, it is equivalent to spending 50 lakh Indian rupees every day from your birth up to 80 years of age. Now, let's come to the why part. Why is India even investing so much money in space when majority of its population is living below poverty line? As a nation and as an individual, what is it that we want? We want to live better quality life, to have enough to spend, to get good food, and to live life on our own terms. To help a nation achieve all of this, we need to remove certain obstacles in our path. And these are poverty, education or skill gap or literacy, and quality of food. If we want to have good food, we need to have proper means and methods for agriculture, right? Around 55 to 65% of Indian population are directly or indirectly dependent on agriculture. Some of the ISRO satellites that we have deployed or will be deploying or have deployed help detect the stress level in our crops. So just imagine. They track the vegetation cover in all lands, where there is overgrazing, where there is degradation happening, so on and so forth. These satellites monitor weather patterns and extreme weather events and provide us with a forecast that help us as an individual and also farmers and other folks with the planting, irrigation and harvesting schedules. The insights from these satellites help farmers know when to sow which crops. Satellites also manage our supply chains by monitoring how much crop is getting produced and at what time we are harvesting, thus maintaining the supply and the demand component of it. Next, if we want to eradicate poverty in India, we have to bridge the connectivity gap and also the education and skill gap that exists in the country. This requires also high caliber teachers and professionals from across the country educating rural children through e-learning portal or social media platforms. Disaster management. These Earth observation satellites aid in predicting natural disasters like cyclone, flood, drought, and it minimizes human and economic losses, as it provides real-time data from the satellites, which helps in relief and rescue operation. We also need satellites for defense applications. They play a crucial role in border surveillance, missile defense systems, and secure communication for armed forces. Final notes. A robust space program is strengthening India's position in geopolitical negotiation and global policymaking. Such high-caliber programs tell the world that India is a superpower and not a third-world country. As much as India needs the world needs India even more. Such advancements will help strengthen our currency against the world and will also stop brain drain, alongside providing a big boost to our economy, creating multiple jobs in different areas, enhancing and improving different types of business and startups. So you see, an ability which might seem really easy from the surface and a program which apparently has no connection to our daily lives impact us so much that we finally realize that it is something that is holding our lives together in place. Thank you. I hope you liked our piece of content. Also, we are hoping that all of you will be joining our journey, and together we shall celebrate India's success through different means of business, technology, science, space, and social issues, and how all of these together are impacting our lives together. Thank you once again.